Hello, everyone, and welcome back. Hi, it's great to see so many people in the room already. Fantastic. So, hello, GM. Hi. Awesome. So while we are waiting for our speaker to join the stage, feel free to pop a little hello in the chat. So welcome back to... Hi, Aaron. Hello.
Hey, everybody.
Fantastic. So we are about to start our second session in this Encode Polkadot Educate series. Today's session will be a technical deep dive into Polkadot, led by Aaron from Parity. So this will be the second of 8 events in total in the series, and a lot of you will have come to the first one 2 days ago. We will be having 2 every week on a Tuesday and a Thursday. So for the next 3 weeks, make sure to sign up and follow along. But without further ado, I will pass over to Aaron to get started.
Hey, everyone. That was wonderful timing on passing it over, because there is apparently like 90% of the police in all of Paris currently driving past my window. So apologies if everybody suddenly can hear all these sirens. It just went absolutely crazy the moment you said that over. So, but yeah, thank you for that introduction. I guess I should start my screen share and we'll get going.
Absolutely. And while you're doing that, I think I will probably leave the screen, but I will be in the chat, as will everybody else.
Hi, so hopefully you all can see this now. Yeah, as you can see probably at the top of the chat there.
There we go, all good.
All good, awesome. Yeah, so as you can see at the top of the chat, there is my Twitter in there. My name is Aaron Bassett. You can find me pretty much everywhere online as Aaron Bassett, because I have zero imagination. So on my Twitter, GitHub, the GitHub's a really important one because I'm going to do some live coding. Pretty much all of this is going to be live coding today. And as I'm working, I will push it all up to GitHub. So if you all want to like check it out later or follow along as I work, it's all going to be on my GitHub profile, which is also Aaron Bassett. I saw some people posting LinkedIn there. I don't know if LinkedIn's cool or not still, but yeah, I'm on LinkedIn as well. And as mentioned, I work for a company called Parity. For those people who are not familiar, you're probably more familiar with Parity's. Well, yeah, we're probably most known for Polkadot. So I'm going to be talking a bit today about the technology behind Polkadot, what we actually use to build Polkadot, the relay chain, Polkadot, what's used to build like the parachains, also what can be used to build sovereign chains if you wanted to go that route as well. And we'll be looking at really how you would use Substrate, which is our blockchain framework, to build out your own parachain or your own sovereign chain. Or really, if you wanted to, like Polkadot itself is a Substrate-based framework. I think I have it over here somewhere. Yep, Polkadot. So you could use Substrate to build your own relay chain. You know, you could use Substrate to build your own version of Polkadot if you really wanted to. Like, it is an incredibly robust and feature-filled framework that allows you to build really any kind of blockchain, whether it be a parachain, relay chain, sovereign chain, whatever it is you'd like to construct. Now, we have a little under an hour left today. So as you can imagine, getting through that is going to be quite quick-paced. So if this piques your interest, obviously you're going to have the rest of the Educate sessions as well. But I just want to draw people's attention to a thing called Polkadot Blockchain Academy. I'm a recent graduate. I just graduated from the Buenos Aires cohort, which was held earlier this year, just a month ago, really. The next cohort is currently open for applications if people would like to apply for it. It is a 5-week intensive course on all things blockchain. So really starting from the very, very ground up, looking at cryptography, looking at tokenomics, looking at game theory, right the way through to like how to use Substrate, Freem, smart contracts, XCM, our cross-consensus messaging, really everything you would need to know to become a blockchain developer, and especially a Substrate developer. It's going to be, if this piques your interest, there's going to be, the course is like 5 weeks of this. So I definitely recommend checking it out. I think the link's probably in there as well. As I said, applications are open. They've been open since last week. We opened them during ETH Denver. I know for my cohort, they were open for about 2 weeks, and then they closed the applications because they received so many of them. I think they received like 750 applications for maybe 65 spaces. So if this does sound like something you'd want to do, if you do want to go to Berkeley for 5 weeks and learn all about blockchain, then I would recommend that you apply with haste. Okay, it is, I just saw a question in the chat saying, is it online? No, unfortunately not. It is all in person. It's a really intensive course. Like, you start your day at 9 a.m. and your class doesn't finish till anywhere from like 5 p.m. to 7 p.m. And then you have your coursework and assignments and things to do in the evening. Like, it is 5 weeks off, like 16-hour days, but it is incredibly worth it. I highly, highly recommend it. I know it's a big commitment to go somewhere for 5 weeks to do that. But yeah, if you can do it, I would definitely apply. So I mentioned there, we're going to talk about this thing called Substrate. So Substrate is our framework for building blockchains. It's all in Rust. And not only does it power like all of the parachains and things, as I said, it also powers even Polkadot itself. So like, if we go look in the runtime here for Polkadot, we can see like we got Kusama in there, we got Polkadot, we got Rokoku, we got West End. So let's look at Polkadot's. Let's look at its cargo, and we can see all the ones in here are all powered by Substrate as well. So you can really use Substrate to build.
Sorry, just to interrupt. Yeah. I think you've stopped sharing your screen.
Oh no, sorry. I will bring that back up again.
No worries.
I don't know how that managed to stop. Here we go.
Awesome. There we go. We can see it.
Sorry about that, folks. Okay. So yeah, so what I was saying is we're going to run through Substrate. This is the Parity Polkadot repository on GitHub, the open source repository. And if we look in the runtimes here, we can see we have like the Polkadot runtime, we have the Kusama runtime. You know, these are all the different relay chains. So we look at the Polkadot, and we can see in its dependencies, like, it is all built with Substrate as well. So like, literally, you can build everything from a parachain to a relay chain to your own like sovereign chains using Substrate. And what Substrate gives you is a bunch of what we call palettes. So Frame is like our modules that you can use to build out your own blockchain. We've got a bunch of them that we've created for you to make to cover like most of the common use cases you may have whenever you're building a blockchain. You know, we have things for doing assets, for doing consensus, for, you know, doing balances and bounties and contracts and governance and everything else you could possibly, well, not possibly, everything else you're likely to need to build out your own blockchain. So a lot of the work has already been kind of done for you. A lot of the heavy lifting's already been done there. And then to help you kind of get started with it, we have this Substrate node template. So the node template is a combination of two things. It's a combination of a runtime that's already been configured. I should mention, this confused me whenever I first started at the Academy, is node here means like blockchain node, not node the language, okay? So everything we're gonna be working on today is all in Rust. I just know whenever I came to this, whenever I saw node, I assumed, you know, like node, JavaScript. No, this is node as in blockchain node, not as in the language. So this is a blockchain node, a Substrate blockchain node template, and it's going to give you like a pre-configured runtime. It's going to give you like a example of a palette, so one of these here that you can work with. So I'm going to quickly create a new repository from this, and we will call this like stream example. I'll make it public so y'all can go and grab it if you want as well. We'll just create this repository. This is all going to be live coded today, by the way. So excuse me for any like typos or errors and stuff. We will work from as quick as we can. And let's go pull this down. Okay. So we have that pulled down. Let's cd into it. And we'll open this up in our editor here. Okay, so we've got a bunch of stuff. All of the things from this repository have all been pulled down. Now, what we're mostly going to be looking at is this palettes template, which is like our generic or example palette that's been created for you. That's what we did most of our coding at in today. So that's where I recommend kind of checking out most. If people want to look at this, I will drop it in the chat. So you can all, I'll push up as I'm working on things. You can all see it as well. And basically what we're looking at today is like creating a really simple palette that allows us to like store some values, emit some events, that kind of thing. And we'll interact with it through like Polkadot.js and things as well. What I should mention, I'm going to start building this actually because it can take a little minute to build a release here. So I'm going to start this build. So this is going to pull down all of my dependencies, and it's going to actually like compile the node in dev mode and start running it for me. That's going to take a moment. While that does this, I should point out that whenever you're first starting off, if we go into the Substrate Docs and into the Get Started, there is this like quick start, and this is before you begin session. And things I'm not going to cover today is this installation. Okay, so installing all of the dependencies to get working with the Substrate node template, there's quite a few. It's broken down by operating system here. I'm on Mac, so it's different things like making sure you've got, if you've got an Apple M1, you got Protobuf installed. There'll be things here around like different Homebrew installations. Make sure you've got like OpenSSL. You've got like your whole Rust environment there configured, there's Rust seeds installed, etc. Good thing to point out is this does require nightly on Rust, so make sure that you're running nightly version. There's a bunch of things in here that you're gonna have to run through first before you can get to this point, which is actually building out the node. I'm not gonna run through them today. I already have my environment set up, as you can imagine. The reason we're is it does take, like, even just building out a single node, as we're running for this dependencies here, as you can see, takes a considerable amount of time. If I was to go through installing all of the prerequisites as well, that would be our session gone. We would never actually get to any code. But there is really good instructions here on the Substrate Docs for each of the different operating systems, installing the Rust toolchain, etc. Run through those first, and then you should be able to get the Substrate node template up and running as well. Is this very similar to the next palette tutorial from Substrate Docs? Yeah, be pretty similar. I'll be walking through kind of stuff as we're doing it, but yeah, it's going to be similar to that, Kelvin. So how are we getting on? We are still building. I said this is going to take us a little moment or two, but I wanted to show you like the default that you get from the node template. So we can go look. Let's actually go look at some of the code while it's building. We're going to go into this palettes template source, and everything's going to be in the librs file. That's where we're going to be working at today. So this librs file, when we first open it up here, we can see it's got some stuff in for us. We've got a bunch of different macros here. We've got our frame support palette, and we're declaring our actual palette. We've got some imports. We're bringing in, different things here we're going to be using. Then we get into our config. So we've got like a couple of things we need for our runtime. I'm just going to skip over those for now. And then when we get into the actual custom code of it. So the nodes template one has just a simple storage here. We'll talk about what the storage do in a second. It has an event, it has an error, and it has a couple of dispatchable functions, or extrinsics as we call them. So these are the things that you'll actually be able to call on the palette. These are like the functions that you'll be able to call, and it will do something. They'll have your kind of business logic in there. How are we getting on? 925 out of 945, almost there. So this one, it's got two extrinsics, one called cause error, which as it sounds would cause an error if we call it, and one that is just called do something, really descriptive, lovely names here. The the do something, it is going to store a value, whatever this something is, some U32 value that we're passing into it. It is going to store a value, and then it is going to emit an event saying that it stored something and who it was that stored it. Really simple, kind of extrinsic. And then our cause error, it's going to check to see if we currently have something stored. If we do not have something stored, then it is going to raise an error, this none value error. If we do have something stored, so we can see here we've got this U32, it is going to add, I think, to our U32 and check to make sure that it's not going to overflow, and then it's going to put that into our storage as well. Okay, so let's see, almost there, 4 more to go. And the storage itself then is this line here where we can see it's just got a storage value. We're going to talk about what this underscore means, but the U32 here is where we're saying what the type of the thing that we're storing is. So that U32 is why we're also passing in here, this U32, and in our cause error, we're adding something, to a U32. We can see here it's defining our type there too. Other things to kind of note really quickly on these is these call index. So you can see here we've got a call index of 0 and a call index of 1. It's really important that these are different each time. If we try to set these to the same value, it's going to give us an error. So projects will run here, and we'll see, call indices are conflicting. Both functions do something and cause error are at index 0. So we need to make sure that we always have a unique index for each of our collables. We are so close, people. 944, 945. Don't worry, it shouldn't take this long to build each time. This is just the first time you build it. It's going to take a considerable amount of time to build. But we are almost there. And what's going to happen once this is built is we're going to look at it in Polkadot.js, which is this. So this is Polkadot.js. It's a great way for kind of exploring chains, etc. I'm currently connected to the Polkadot relay chain here, and we can see different events that are happening. We can see like this balance transfers being done here. For each, we're currently on block 14,672,851, and these are each of the events that are occurring on different blocks. We can go into them and see the different events that have occurred, different extrinsics have been called, etc. This is what we're going to be doing, but for our own node that we're currently, and it's built. Okay, so this is our node that we've built locally. It's now running, and just like we're connected to the Polkadot relay chain here, is we can actually connect to our own chain development. We're going to go local node. We're going to switch to that. And let me see, let's refresh. Oh, because I'm at a node, it doesn't exist for this one. Let's go back in here. Here we go. So yeah, we didn't have 14 million or whatever that block number was to look at, because we're only at like block 11, block 10, block 9. You see there's been no recent events on my little local chain that I'm running, but we can go and we go into extrinsics. And under here, we can see we've got this template module. That's the one we just created. And it's got those two functions to do something in the cause error. So let's call the cause error first. And as expected, it causes an error, this none value. That's what we had in our code here, that if there was nothing stored, it should return this none value error. And if we then go do something, and we're just going to store a value, and we'll submit that as well. Give it a second. Here we go. Okay, so that's completed. We can go back to our Explorer, and we can see, here is our recent event, something stored, and that recent event will correspond to our event here that we emitted. Okay, so we can see something stored is the event, something stored, something, boo, etc. And that was what we called from inside this dispatchable function here, was deposit event. So deposit events are really important. It's how you notify anybody who's kind of looking at this view or subscribe to events when something has occurred. And then also, obviously, errors are really important as well. So you can notify folks whenever something's gone wrong. We're going to modify this now, and we're going to do something a little bit more interesting with the storage value. We're going to see how we can store value and then how we can actually change that value. People may have come across it before. It's commonly known as like flipper, because you're flipping a Boolean between like true and false. So we're going to keep the same kind of storage here. We're going to get rid of this something. I'm going to call this like single flipper value. It's still going to be a storage value. What we're actually going to do here is what we'd expect. So if we're going to be flipping a Boolean, from true to false, is that we would then store, in here. Okay, we're going to store a Boolean. Because what storage value is taking here is two things. It's taking this, which is called a prefix. So if we wanted to like put our own prefix in here, so that each storage item had a particular prefix we could look for, we can modify this. Most of the time you're not going to. You're just going to like put an underscore, which means like, I don't want to change the prefix. Just I'm good with what Substrate sets it to by itself. And then this is going to be the type of the value that we're going to store. I'd say we're going to like do a Boolean, so let me flip it back and forward. But what we can actually do, because this is just like a single storage value, we can just check to see if it exists. So let's just put like, our unit type in here. And save ourselves a few bytes. We don't actually check to see, like, is this true? Is it false? We can just check to see, does this value exist? And if it exists, then it's true. If it doesn't exist, then it's false. There are things that we can do in here then is change our do something function. So we're going to update our do something function, and we're going to give it like flip single value. So let's just do that. We're not going to pass in anything into it anymore because it's going to be like, if it's true, set it false. If it's false, set it to true. We're going to keep our who in here. Now, the thing is we're no longer actually going to use this who. We do still want to call this line though. And the reason we want to call this line is because we want to ensure that this call is signed. Like if we look here, whenever we were looking at our extrinsics, we have the option of doing a unsigned or a signed, and pretty much anytime you're doing anything, you're going to want it to be signed. So this is how you ensure that the origin, so the person calling the function, is signed. So we're going to keep this in here. We're not going to use this value though, so I'm just going to prefix with an underscore, which is Rust's way, or my way of telling Rust, yes, I want to call this function. I know it has return value, so I'm going to assign it to something, but I'm not actually going to use this variable anywhere else in my code. So I'm going to set it with a prefix first so that the compiler doesn't shout at me about unused variables. Then what we're going to do next is we're going to take this out and we're going to check to see if it exists. So we can do like if, what do we call it? Single triple value. On generic T, if it exists. So we're going to assume then that it is true. If it does exist, then we're going to do single flipper value, and we're just going to kill it. Okay, so I spelled that correct. Single flipper value, yeah. So we're going to kill it. So we're going to delete that entry, and then we are going to deposit an event. So we're going to say our event is going to be flipped single value. And remember to say that our current state is going to be what? So it's going to be false. And then else, if it does not exist, then we need to create it. So we can do single flipper value, and we can just do put an empty unit type. Okay, so now we're creating that entry. It doesn't need to be set to anything, that's fine. Let's emit our event saying this time this is true. And we can get rid of this. This okay at the end is because our dispatchable functions all return this dispatch result. So dispatch result can be either okay, or it can be a dispatch error, a runtime error. And that's really important. We never want to panic inside any of these functions because that's obviously can be very detrimental for our chain. So we have to make sure that anytime we're always returning this dispatch error, that we're making sure that, like, we're catching any errors, that there's no way our code can panic, and that we return a dispatch error. And that's fine. You can return dispatch errors, as we saw when we called this cause error, which we can take out now. We don't need this anymore. Whenever we call that cause error, our chain knew how to handle it. It just presented the error to the user. There was no issue at all with returning an error. Just make sure that it's one of these dispatch errors. Okay, so let's save this. So we do not currently have an event called flipped single value. So let's go create that. We've got our events enum up here, which has our something stored. We're just going to create it underneath it. We're going to say that is a Boolean. Okay, so we're going to flip single value. We've got our new flip single value dispatchable function here. If it exists, all seems good. So let's save that. We can go back. Let's kill our current node, and let's try building it again. As you can see, thankfully, I don't need to go through the whole thing again. We just have a little bit to build for my few changes. And it should hopefully build in a second. So this is like just storing a single value, so there's no kind of way. It's always going to be just looking up under the single value here. We're going to look next at how we can store multiple values, but this is kind of the most basic kind of storage that you'll use with Substrate. So good thing about in Rust is, okay, it does take a little bit of time to compile and to run, but it does shout at you a lot as you're working. So if you make mistakes, like if I was to forget to put that underscore there, it's going to shout at me and tell me, like, yeah, we go. If there's an intentional prefix of an underscore, unused variable, yada, yada. So yes, it does take a while to compile, but thankfully, as I'm waiting for it to compile, or I don't need to compile it very often, I can write a lot of code in between. Okay, so that's running now. Let's go back to our extrinsics again. So this has changed now. Under template module, we no longer have those two dispatchable functions, this flip single value, and we can submit that. Okay, we go to Explorer, we can see, current state, yes. So it didn't exist, it now exists. If we call it again, yeah, thanks for that, Manuel. Yes, origin represents the caller. So that's why I'm like looking for always to be signed in this instance. So this is you see here, it's auto-completing my type for me, which is a type of account ID. And that's just getting passed in here. I'm going to use this ensure signed with the origin to make sure that the actual call was signed. If I try to submit unsigned, I'm going to get an error. Okay, you can allow unsigned. I'm not sure the use case right now doesn't occur to me. You can allow unsigned as well, but 99% of the time you're going to want to ensure that it is signed. Other things you can do as well is you can ensure root. So this is just like a regular call. There is also the possibility for you to ensure that it is a root call. So root calls are essentially wrapped in like pseudo. If we get time towards the end, I can go into that more, but 90% of the time, this is what you're looking for, is this ensured sign. Okay, so we saw that worked. I think I flipped it back. Yep, no, call it again. It would flip it back to yes. Really simple, single value being stored, single Boolean being stored that we can flip back and forth between true and false. But what if we didn't want to store a single value? What if we wanted to store, like, because this is for the entirety of this chain, probably not going to want to store a value that can be changed by everybody and is also relevant to the entire chain. So let's do one that is for my account, for this origin being passed through. So we're going to create a new storage type. Where is my storages? Here we go. Okay, so we're going to create a new storage. So it's going to be like our palette storage. but I think there's probably, let's just, yeah, okay. Storage. And then we're going to create a getter for this just to make it a little bit easier. So I'm going to do palette getter, and it's going to be what we're going to call our getter per account. There we go. So these getters just make it, it's just a shorthand for being able to reference values that have been stored. I'll show you how to use that in a second. And I'm going to create a new public type. And this public type is going to be called per account flipper value. And rather than being, I'm going to need to tell it in here that, because this is a generic, we've got our, oops. It's going to be a type of a storage map. Okay. A storage map is going to take some different options than what we currently see here in storage value. It's going to take a prefix as well. I'm not going to change the prefix. I'm happy with the prefix that I'm going to get. But the next thing it's going to want for me is a hashing function. So I think I've got some information on here. So yeah. So there's a bunch of different hashing functions that are available for storage map. I don't know if I have a list of them in here somewhere. Let's see. I'll find them later and link them. But essentially, switch on map, hasher. Yeah, let me just get these for you because they are quite important. Okay, so we're in our runtime storage structures. You can see here it's got like our storage maps and things we're talking about. But one of the important things is our cryptographic hashing algorithms. There are 3 main ones available within Substrate, Blake 128 or 2x64 and identity. The Blake 2 128 is what you're going to use most of the time. Is what you'll see me using every time here. And the reason that we're going to be using that is it is going to be the key to our hash map. It's what we're going to be looking things up by. Now, there is one identity. Identity will not hash something. Identity just stores the key directly, as you can see here. The reason we don't want to store the key directly, the reason we want to use a cryptographically secure hasher is because of trees or tries. For anybody who's not seen one of these before, this is how things are stored. We're essentially, so if we're looking at the words T, TED, and 10, so the less hops we can do, the better. But in this instance, if we're storing 10, what's going to, okay, go down T, then TE, then TEN. But it could also be T, TE, TED, T, etc. So we can see a number of hops we've got to do to each one. If you do not use a cryptographically secure hashing function, then somebody could create an unbalanced trie. If in our code here, with whatever I'm going to be using as the key to our storage map, if I let the user supply that and I didn't hash it, so I used like this identity hasher, I stored the key directly, then somebody could create a bunch of storages. They could store a lot of data in my trie, all with the same starting characters. So imagine here that like every single thing starts with T. So suddenly my trie is really unbalanced, and every time I'm looking something up, I have to go multiple levels down. So it's really important whenever we're creating any of these keys for hashing functions that we use a cryptographically secure hashing algorithm so that it is uniformly distributed. If we allow users to create these keys themselves and we do not hash them, then somebody could create an unbalanced trie. They could force every time that you need to do a lookup within your storage that you have to do many, 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 many hops, and you now have a denial of service attack on your chain. So a really important thing here is to choose the right hashing algorithm. And honestly, 9 out of 10 times it's going to be this one, okay? Only use identity if you're sure that it is already something that has already been hashed with a cryptographically secure hasher. So something you've hashed, not something that's coming from the user. But any other time, you probably want to use this Blake 182. So that's what we're going to use in this instance. is we're going to do our boolean 128 concat. And what we're going to use as our key is the person's account ID. So that thing's going to be an origin. And then we're going to specify a couple of other things here. So the thing we're going to store is a Boolean. This time we're going to store the Boolean. We're not going to do that like is exists thing. We're just going to store the Boolean so we can look at some of our stuff. I'm going to say this is a value query. And we'll talk about that in a second. And because it's a value query, I'm also going to supply a default for it. So I'm going to say in here, we're going to have this like per account flipper default. Okay, and I'll define that in a second. A value query, the normal way a storage will work is that whenever you query it, it's going to return you a result set. And that result will either have the value or it'll have like none or an error, one of the two. Yeah, error, sorry. In this instance, because we're specifying this is a value query, what we're going to say is if you can't find this, if you're looking at something up by this account ID and it doesn't exist, then I want you instead to return this default. And that's what we're going to specify next is what this default is. So I think, oh, it's missing a semicolon. There we go. I need to define this default. So it's going to be a, I need macro of palette, type value, and then we're going to do public function, and it's our thing we just defined there. We're just going to take our config. Oh, sorry. Oh. And that is going to return a Boolean, and we're going to say our default is going to be true. Okay, so here we go. We've got our default function defined. It's going to return a Boolean of true. So anytime we try to query this for an account ID and it doesn't exist, then we're going to return that true function instead. So let's go down here and create our next function. We're going to change our call index. I like the increment in tens. So if I forget one, then like it's really easy for me to add one in without having to go and renumber all of them. This time we're going to be doing flip account value. We don't need to pass anything else in because somebody take out origin 4. People are asking, okay, so what is an unbalanced try? Unbalanced try is where if we look at this diagram again, where one side of this would be really, really uneven. So if we look at their example here where they have, in T, TED, 10, etc. Imagine that 99% of all of the words in this list all started with T. So you're going to look up a value in your storage map, and you're going down these pathways, and suddenly everything is like T, and then it's like TT, TTT, and it just keeps going. So rather than it being evenly distributed, where some start with T, some start with A, some start with E, some start with R, some whatever else, all the other letters, everything starts with T. And then the second letter of all of them is the same. And the third letter of all of them is the same. And the fourth letter of all of them is the same, and so on and so forth. So suddenly, rather than having to do, maybe 2 or 3 hops to get to a value, you're now having to do 30 hops, because the first 30 letters were all the same. And maybe they only differ, like say it's a 32 character, whatever, it only differs the last character, last 2 characters, etc. That's an unbalanced try, where you're having to do a considerable number of hops to get to each value because the IDs are not evenly distributed. If you use a cryptographically secure hashing function, then all the characters will be evenly or uniformly distributed. So you should never get into a state where you have an unbalanced try. However, if you let the user supply the key for your storage map and you don't hash it, then an attacker could submit, tens of thousands of keys, all with very similar strings. Oh, I think that's going to have killed my screen share because my computer went to sleep. Give me 2 seconds. I'll put that back up again. There we go. Yeah, so really important you make sure that anytime you take user supplied input for any kind of key that you hash it first. And yeah, manuals write storage map is just like a hash map for string key value pair. So where did we get to here? Okay, so we created a new function. I'm giving it a new call index of 10. And we're going to do flip account value. This time we are going to use this who, so I'm going to take that underscore off. And then we can do in here. So we're going to do let mut kind value because we want it to be mutable. We want to be able to change it. And we're going to do that self, what do we call it? Per account. Great. And our per account is going to take that who. Okay, so we've got our account value. If it doesn't exist, you can see here this knows this is going to be a bool because it will provide a default value if it doesn't exist. So that's why we're safe to do that. And then we can do our account value is equal to the inverse of our account value to flip it. And then we can do our per account value. Value, and we are just going to insert, and it's going to be who and this account value. Okay, and that would work. That's enough for us to do it. You know, we're getting the value here, we're flipping it here, and I'm inserting it back in with the same key. That would work. It's not the nicest way of doing it. What I would actually suggest doing is using mutate. So we're going to do per account value, and we're going to call on this mutate. Mutate is going to take the key, so who, and then we're going to have our account value is what we're going to get from it. And down here, then we're going to have to dereference that account value because it's a mutable value, and then we can assign it. Well, okay. Now the difference here from what I did before, we're essentially doing the same thing. You know, we're querying on who, we're getting the account value, and then we're updating it. With mutate though, I think I have some information on it under storage map. We can see here we have mutate. We also try mutate. So try mutate is probably the one I would recommend you use most of the time. I'm using mutate here because there's nothing really that can fail. The try mutate, however, will only mutate the item if an OK value is returned. So this is really important if you're going to be changing like multiple things. You can call try mutate, you know, return a result, and that way, you know, if you need something to happen only if something else also updates, or you know, there's potential where it could emit an error, and you don't want to have to. You don't want to change that value on chain, etc. Then you know these mutate, these closures are your friend. So we're going to save that one. We also need to like do our deposit event. So we're just going to deposit the same event here. But this time, current state needs to be whatever the state is. So we're just going to do our self per account, and we can fetch that for who. Okay, and that should be our Flipper 9 working on per account basis. Let's just go try and run our release here. Just going to build it. So yeah, so we are now, instead of storing just a single value as we stored here, we now have a storage map, which allows us to store a value based upon the account ID. Okay, so you can see it's very similar to what we did before. We got a couple additional options here. You know, so we're now specifying essentially a key for it in our hash map, but very, very similar interface to what we had. And so we're almost there. While that's running, I'm going to move on to the next one just because I know we're going to get really short on time. And that's like if we wanted to store multiple values for a particular user. You know, so here we're still storing a single Boolean value for a user, but if we wanted to store like multiple values, because there's something important we need to know about that as well. Just run through almost. So say a user we wanted to store a list of Booleans. You know, so we didn't want to store a single Boolean for a user. We wanted to store n number of Booleans. So we could still do like our storage map. In fact, let's just copy this here. Let's just say, and we're going to call it what? What are we going to call this? Per account, multiple. The poll can't spell multiple Boolean values. So we're still going to have our account ID here, but instead of storing a single bool, we're going to store multiple Booleans. First thing you might want to think about doing is, okay, well, I'm going to store an array of bool, and we're going to say there's 10 of them. Perfectly valid. You can do that. Okay, that's one way you can do it. Issue with that, however, is, well, it always has to be 10. So in Rust, if we don't know the length of something, well, we could use a vet, And again, you may think this is like, looks perfectly valid. It's a way of storing a list of items of unknown length, but it's of unknown length. And this is another thing to kind of bear in mind whenever you're thinking about storing stuff on chain, is storage is not free. This is, could be of whatever length somebody wants it to be. So again, it's another attack vector. Somebody could create a massive vector in here and use up lots and lots of storage on your chain. Not something you want to happen. So what we have instead is a bounded vec. So I'm going to say a bounded vec of bools, and then for a bounded vec, we give it a max number. So I'm going to do, let's say, I'm going to make this configurable. So I'm going to do, max Booleans per account. I'm going to need to then add this to my, I'm just going to grab this here so we can bring it across into my config. So I now have this max Booleans per account, which is a U32. I now have it in here. My bounded vec, which is max Booleans per account. I'm going to do a different default. So this is going to be a, what are we going to call this? Per account. Yeah, let's put that in, and let's just grab this from here just to speed things up a little bit. Okay. So we've got this max Booleans per account, and we need to add it now to our runtime, because this is a runtime config kind of value. So down in our runtime, we will find that we have some config already. So I need to add that there. So we're going to do max per account. We're going to do a type, and that's going to be equal to that. And then we need to add it in here as well. So I'm going to do pub. Our type is a U32, and we're going to give it a default value of 2. So people can store up to a maximum of 2 Booleans on their account here. Oh, I got an error. Nope, I think so. And we have, oh, these are named the same. That's probably why. Let's take that out. Okay, per account, multiple Boolean values, and we can see we've got like our bounded vec, etc. for it. I'm going to not type, make you watch me type this whole thing out because we're running on time. Instead, I'm just going to bring the function across here, and we'll talk about it. So here we have an add Boolean to account. It's going to take our origin again, so who, and it's going to take a Boolean to add to it. We can see here we can get our list of Booleans, and then we have this try push. So this is going to try and push this new Boolean into our bounded vec. You see here we've got our bounded vec of Booleans. And if it can't, then it's going to throw this storage overflow error. So that means if it hits this max Booleans that we specified, then it's going to hit an error. And let's just make sure this runs while we're doing this. Oh, I mean, we're missing an event here. This account Booleans updated. And I need to add a new event for that. And what does it take? Account Booleans updated has a Booleans, which is our list. So Booleans, and that is going to be the same bounded vec. So we can pop that in there. And yep, we got that error here. Let's start running it again. So I got asked a question in chat about how much Rust would you need to know? Ooh, missing Booleans per account notation. You know what? We are running short on time, so I'm going to grab this whole thing, really cheat here, and swap this in. Hopefully it builds for us. Oh, missing our max booleans per account implementation. Max booleans per account. Max booleans per account. Yeah, we've got our palette constant here. So why have we not run save this? Give this another build. Let's see what happens. Oh. Right. Yeah, I'm just gonna. Sorry, we're updating my runtime. I was looking at my time and I'm like, I have so little time to finish this for everybody and get some questions. So that's why I'm like skipping ahead here and just dropping in stuff I already coded. I know it's like a little bit cheating time, but here we go. Let's get this running. Looking better. We don't have an error straight away. I've obviously just missed something in my rush, but to answer the question somebody was asking about how much Rust do you need to know in order to be able to write a frame palette? Honestly, a considerable amount. To get into the Polkadot Blockchain Academy, I did have to pass a Rust test. And to get, I wasn't a Rust developer before then. To get competent enough to pass a test, I probably spent about 2 weeks learning Rust, both through the Rust programming book and doing Rustlings exercises. And that was enough to get me in the door to go to the academy. And then at the academy, you learn a lot more Rust, but they don't really stop to explain a lot of it. So having a really good understanding of Rust before you start is probably a good idea. We do use a lot, as you can see, of like advanced traits and generics and stuff. And I know that can be confusing. This is still building. I want to just let us have a final look at this before I go into questions. But yeah, we can see here we have the storage overflow is now in there as well. Yep, it's built. So I'm going to very quickly open this up so we can have a look. We now have our extrinsic under template model, add boolean to account, no, submit transaction, sign and submit. And it works. And we can see under here, we got boolean added. Let's do one more. Add boolean to account. Let's add a yes. I can't remember what the setting was. How many booleans were we allowed to add in this setting? Let's go take a look. 2. Okay, so that one should work fine. Explorer, yep, that's fine. But then if I call another one on the same one, submit, we should get an error. So that's what I was saying before. As long as you are just returning a dispatch result, you can return like an error, like a storage overflow error, and that is fine. It will not cause any problems for your chain. Your chain will continue working as per normal. They'll still even get like gas fees and stuff paid for it. Oh, I think it was like maybe 11. Yeah. So like they still paid a transaction fee, but the extrinsic failed. But it was a known error. We didn't panic. It's not going to cause a problem for the chain. So I'm going to call it there. Stop sharing. And have a look at some of the questions very quickly. We've got a couple minutes left here. Okay, so Rust, we kind of talked about there. What I would recommend as well is Brown University does a version of the Rust book that has exercises embedded within each chapter. Let me see if I can get the link for you all. There you go. So if you want to learn Rust, I highly recommend that version of the Rust book. It's free, you can read it online, and there is exercises embedded in each chapter to allow you to test your knowledge and your understanding. And the other one I'd recommend is Rustlings, which is great little exercises to help you improve on Rust. Those are 2 things that I did myself before I started to learn Substrate, and they give me a good standing for being able to learn it. People are saying, oh, I did the pseudo instead of palette template. Thank you, Manuel. Thanks for catching that. Sorry, I didn't see your comment. Macros, yes, macros can be confusing. They're incredibly powerful. We use them a lot within Substrate, but yeah, I can understand why they're confusing. Anything that's going to be like generating code is always going to be pretty confusing. Is a palette and nudgeless to a contract doesn't provide. So the difference between a palette and a smart contract is a palette you have a lot more functionality available to. A smart contract is going to be running on somebody else's chain and is obviously going to be bound by whatever restrictions their chain has. Whenever you're developing with a palette, so you're essentially building your own parachain, your own blockchain, then you're not bound by those constraints. So you can really add in whatever functionality you wish. You can change even like governance, you can change how gas fees are calculated, you can change how people stake, or really endless. So yeah, there's a lot more power in building out palettes than there is smart contracts, but there's also a lot more complexity as well. Awesome. Well, is there any final questions? I'm not sure Angela's saying anything. She's muted, but she's shaking her head. So no.
I think we're good. Cool.
Sorry, that was a little bit rushed. I'm going to be starting a new series on Twitch in the coming weeks, where I'll be doing basically this, but in a much more paced way, shall we say,
Yes.
and also be able to answer questions and things. So if you did enjoy this, please go follow my Twitter. I will drop a link again for it here. Go follow Twitter. I will announce whenever we're ready to start those Twitch streams. And yeah, it's going to be a lot of fun, I hope. And yeah, we're going to build some really cool palettes and some really fun dApps. So, awesome. Link the Twitch account too. It's going to be on the Polkadot Twitch account, which is going to be Polkadot.dev. I will link to that now as well. There you go. So yeah, give that a follow. And one of my colleagues, Sasha, is already streaming on there, doing Substrate seminars. So they're really interesting. Check those out too. And we also do deep dives, I think, every Friday, where some of my colleagues will be doing really deep exploration of each of those different frame palettes that I very quickly skimmed over earlier on. We have something like 50 palettes that do everything, as I said, from like staking and consensus and governance and balances and everything else. And they're going to take a different one each week and do a deep dive into it.
Amazing. Thank you so much for all of the resources, Aaron. That was amazing. Like everything was so well explained. Thank you so much.
You're welcome.
So,
will the code be pushed to repo? Yes, it will be pushed right now. I will, as soon as I get off this call, I will. In fact, you know what? Let's just add everything. Awesome. So that should be now.
Fantastic. I've just put in the link again back to the GitHub in the chat, as well as Aaron's Twitter again. And also for the following sessions in this Educate series, you can sign up again on that link. It's in the chat. Thank you all so much for coming today. And we will be kicking off with session 3 next week on Tuesday. But for now, I think I had a few questions regarding video recordings, and what we'll do is try and send out the recordings just once a week at the end of the week. Then you won't be spammed with so many emails. But I think that's pretty much it. Yeah. Awesome.
Bye.
Thank you, everyone. Bye.